Hello and welcome everyone to the video. I'm Jan Kazinoy. So today I thought I love programming, and one thing I love about it is you can make some pretty interesting stuff, maybe even watch other people making some stuff and making it yourself, implementing it by yourself, using some techniques that you like. So today I decided to make a playlist where I will try making some stuff. I'm not like a computer science major, and I'm not a professional programmer, but I'm a hobbyist programmer, and I guess I'm mildly good at it. So maybe someone will see at least a little bit of value in watching me making stuff. At least how it can be made, not how it should be made. Because listen, I'm not like I'm not a professional, and I'm not a professional, as I've said. And by the way, this is going to be a good maybe opportunity for me to practice my English, because I don't have much time spent at this. I haven't spent much time at this for a long time. Like for a year, I almost haven't talked and spoken English, etc. So yeah, it's a win-win situation for me, for my programming skills, for my English skills, and maybe for you if you would be interested. So today I wanted to make my implementation of the game 2048. Maybe you know it. Drawing. Okay, so what we'll have here is a 4x4 grid in which the numbers be stored, and the numbers will be only like powers of 2, so 2, 4, 8, 16, etc. If you are at least a little bit familiar with programming, you will know pretty much at least 10 of them by heart, etc. So what we will implement is a little game. A number will spawn. Each step, a number will be spawned. For example, a 2 will spawn, and we would be able to either press the right arrow key, down arrow key, up arrow key, or left arrow key, and the number will go either this way or this way, etc. So when it will go from like left to right, for example, it will scan each of the subsequent cells in the grid, and when it will see a number, for example another 2, it will delete itself and increment this by itself, so they will merge into a bigger number, twice this number. So for example, we will have this configuration. We go right, and then this 2 will go here, then they'll swap and become a 4, and then this 4 will go to the end of this like line. It will go into the next cell and the next cell if there will be any, but there wouldn't in this configuration, so it would stay here. And yeah, so we'll the initial configuration is 2 and 2 here, and then we go right. They will all go to the right and merge together and go to the end of the line. I hope you will. I hope you are familiar, at least, with this concept. So the game is named 2048 because in the original game, in the original implementation, you only needed to go up to a 2048 to win the game, but we will not have this limit probably, but we can like make a notification for the player that they have achieved the goal, but they may continue playing. So I'm on Linux, so if you are on Windows or you are just not very familiar with Vim, NeoVim, console, or I mean terminal, you may use your tools, but I'm here on Linux, so I will make new directory for these videos. I'll call it I don't know, video stuff. I will go into change the directory, the current directory to the video stuff directory. I will make another one, mkdir 2048 cd 2048, and I'll make two files. Touch, again, you can do it in your whenever you want, wherever you want. You may follow me, you may not follow me, you may follow me, follow this tutorial in another language if you so desire, but again, so we will make main.c and make file. I'll already go to make file, open it with NeoVim, and I'll make a build configuration. I will need main.c, and the output will be gcc main.c o main. Yeah, that's all. And we will use Raylib. That is a graphical library. This is my favorite graphics library for C, but if you do have another graphics library or you use another language, you may use what you want. And we will probably need the math library. And then we have run configuration. It would require build configuration, and it will just like execute the program. We'll go out of it and vim main.c. So first things first, we'll need Raylib. Again, I use Raylib, you may use whatever you'd want, and stdio.h. We'll try making a simple program to just check if everything works. Print hello world. So I have make run binded to F5 key, and yeah, it compiles, it works. So then we'll need some boilerplate for the Raylib library. It's init window, and init window takes in widths. It will probably be like 2020. It will be a square game, so 800 by 800, and a name 2024. It will like while window should close. It doesn't work, unfortunately. While window should not close, we will execute the loop, and if it should close, for example, we press the escape key, we disable the window. So close window. Okay, it doesn't want to work. It's fine, whatever. Begin drawing. In drawing. It just doesn't work. Okay, we'll spell everything by ourselves, by our hands, if it so desires. And here we will need to clear background. Clear background with color gray white. Okay, I think the boilerplate code is done. So we'll have a map, a two-dimensional map. So it will be type integer, and it will have 2 dimensions, as I've said, and it will be just empty. I can actually just initialize it like this, 4 by 4. Let's not make any magic values. Okay, I have here some magic values, but whatever. Let's define like height. Let's define the map size. It will be 4. Map size. Oh, it works. Magically, it works. Want it to work this time. So, when we initialize an array in C on the stack, it is automatically set to all zeros. So we don't need to do anything just now. So what we will have here is a global variable. This global variable will be the map, so we don't need to pass it in every function that we make. And we will just populate this map with one value. For example, the very first value will be 1. And why will it be 1? Because we don't need to store the exact values of the cell. We only need to store the power, because every possible every possible value is a power of 2. So we only need to store the powers. So a power of 1 means just a value of 2. The power of 2 will mean the value of 4, etc, etc. And for example, we can show the empty, we can encode an empty cell by passing in 0, but it is always set to 0 at the start. So we here will initialize a cell to a value 1, which means 2. Okay, so what we will have, what we will need in the first place is a way to show the map, for at least an empty map. So we will need a map draw function that will actually doesn't need to, we don't need to pass anything, because the map, as you know, as I've already said, is a global variable, so we don't need to pass it into functions. I know there is a possible like drawback to using global variables, but a map 4x4 type integer, it's like what, 4, 4, 16 by 4 bytes is 64 bytes of memory on the stack is not a really big number. So what we will need here is a loop that will loop through every value. We have two axes, so the first one will be let's actually, okay, no, never mind. Let's use the standard integer type for every integer values that we need, because I don't want to overcomplicate things here. It will need to loop from 0 to map size, and it will need to actually increment each loop cycle. Then we create another loop inside of here, and this loop will go through all of the x values. And then here, so in Relief we have a good function, draw rectangle. So as the first value, it takes rectangle position, x and y. No, as the first and the second value, and then the third and the fourth value is its size. So the position will be like x multiplied by some value that we haven't yet defined. We will need to define how big will a cell be on the screen. So it will be like cell size, and so let's think. We have an 800 by 800 window, and we have 4 by 4 like cells. So probably a cell size will be 200. You can change it if you want, but I will have it set to 200. Or I didn't use it right yet. So x by cell size, y by again cell size, and here we only need to provide the cell size and cell size. Okay, and the last value is the color, but the color here will be like, I don't know, red white probably. And we probably want to have an outline to all of this, so we can just say draw rectangle lines. We have position, position x, position y, width and height as well, so we don't really need to change anything apart from this color. The outline will be black. I will make it black, and yeah, I think that's all what we need here. Let's try to do it. Let's try using this function, and let's compile our program. Yeah, so as you can see, we have a 4x4 grid that is arranged like orthogonally, 4x4 tiles, and we have black outlines as we need it. So then when we draw, we actually want to check for the values. If we don't have a value, what I mean by that is, if we have a 0 value, then we will not draw any tile. But if the value will be more than 0, and we will put the value over it. So let's make this right. So if map x is not 0, but it's actually like implied by this construction, is it will be true only if it is not 0, so we don't need to change anything here. And yeah, like my Vim may lag a little bit. So if there is a value, then we want to print that value to the map. We will not do anything complicated. Firstly, in C you can't just pass an integer as a string because it is statically typed, not like I don't know, Python or JavaScript without TypeScript. So, and it doesn't have this like fluidity that print functions that like Go has, or again Python has. So we need to pass this value firstly. For example, like we can make a new char pointer, which means just a string in C, and like value equals s print, s and print. Let's make it s and print. Oh, I forgot. I totally forgot. You don't want to. You want it's like that. So char value. Let's make it like in the tens. So what I do here is I need to define upper limit on the amount of characters that the string may have, because I code in the C language, and C language, it doesn't have a garbage collector, and it stores its like strings in a very interesting way. So at the end of the string you have a zero byte, and the 0 byte is like a null termination byte. So the program, when it needs to print this or use in any way this string, it goes from the 0 byte to the next, to the next, to the next, to the next, and prints out this byte as a character. But if it encounters a 0, it doesn't go past the 0 value. But if you don't have a 0 value, you are pretty much doomed to print all of the stack, or cause an segmentation fault if you try to access data that you don't have access to. So I will need to specify the exact value. I think 10 will suffice. Yeah. Oh, I just forgot to put an n in here. So print takes the first one is the string that I need, so like value, then maximum length, so 10, format is %d, and because it's an integer, and %d is means to output an integer type, and then like I guess 2 to the power of whatever value this cell has. But to implement this we need to have a power function, and we don't really have a power function in the standard library if you don't include. So we need to include mass.h. We already included it in our compiler. So if I go here, I told my compiler to compile it with the mass library, but we can also not really do that. So let me show you a clever way that you may use to impress maybe someone in your maybe impress your friends, or if you don't have friends, impress your mom, I don't know. So So because computers have use binary in to like encode different values, you may also like use one clever trick to increment by 2, like I don't mean increment, but multiply by 2 a value by 2, or to decrease the value by 2. So because values are stored like in a sequence of bits, 0, 0, 1, etc., you can just push the value to the left by 1 bit to multiply the value by 2, and push the value to the right by 1 bit to decrease the value by 2. So I will do this. I will just push the value by the values that we have here. Yeah, like this. So now it should store the value that we have here, like the to the power of the value of the cell. It should be stored in the like value variable, and then what we need is to print this value. We use draw text, and here we pass the value, const char pointer, and position, the position that it will be shown at. So position will again be x by cell size and y by cell size, and the color, the font size will be, I don't know, probably like if the cell size is 200, then the font size is probably like 64. So we'll store it, not exactly store it, but use it by a macro, and then the color will be black. But that's not all. That's not really what we want, because if we will just use this as our code, then the value will be displayed over our border, over the outline, because we need here to make it plus 0.5, and here again plus 0.5, so it will be displayed in the center, at the center. It will be displayed not really correctly, because like it will start at the center, but then the text will go to the right, and the overall text will be shifted to the right. So we can try to overcome this, but that's not really a point. It's not really the point. We just need to see the value that is stored. Here I made a mistake. I put it like this, but this is not the way that you do this in C. You do this way. You do it this way. So okay, let's look. I think we did all that we need. Let's try to run this program. Yeah, so it didn't really go well. So here I foolishly put not the needed value, but another value. I put the cell size, but there needs to be not a cell size, but the font size. So now if I run it, yeah. So now if I run it, it works. No, it doesn't really work well. Okay, I know what the problem. Is. We don't need to push 2 by this amount, but we need to push 1 by this amount. Because like 2 to the 0's power is 1, but here if we push 2 the value of 2 to the right 0 times, it will still be 2. But if we push 1 to the right, wait, to the left, sorry, to the left, if we push 1 to the left 0 times, it will be 0. So again, let's try this. Yeah, so it works. It works, then this means we can continue. So back to the drawing board. So suppose that we have this value 2, but now we need it to move to the right. So how it will do this? It will go to the right, check if there is another value, go to the right again, check if there is another value, go to the right again, check if there is another value. If there is none, then it can't go anywhere else anymore to the right, so it stays the same. Let's then go to our code, and we need to implement this. We will need like to check for our keys. So I will have an key like keyboard handler handler for this stuff, and then this keyboard handler will not take any values in. And now the Raylib library provides us with a way of checking if a key is pushed. It is simply is key pressed. Yeah, so if is key pressed, and then we okay, and then we just provide the keys that we need to check. So key, if the key like W is pressed, we need to check for that, and let's make another value, global variable, and let's make it like direction, and let's make some direction, like direction north, direction south, direction east, direction west, and let's put it here and here, so it will go counterclockwise starting from the north, and the north will be 0 value, east will be 1, south will be 2, and west will be 3. So then this direction will be 0 by default, and yeah, then direction, if we push W key, it will go up, so direction north, and we need to check for the other keys. If the key is S, then the direction is south. If the key is A, then the direction is west. And if the key is E, direction is east. So every time we change the direction, or maybe not change it, but just if we make the direction some value, we will need to act on it immediately. So we will need another function like move void move piece, move cell, and here we will provide the direction. No, we don't need to provide the direction because we have the direction as a global variable. So we'll need to go one by one. For example, let's just cover one case. If dir equals north. No, let's make it if dir equals east, because our current non-zero cell is at the uppest leftist corner, like north western corner. So if the direction is east, let's go through every of the like int y, go through every of the y rows, go through every of the rows, and from 0 to map size to 4 in this example, and we'll increment it, and then we will see if let's do this. X change it to x, and then if map at this let's do this the other way. Let's make a new variable, like store the current value of this position in a variable. Then we will check if the subsequent position is not occupied. We will push the previous position to the next position if it is occupied, and the value there is the same as the value here. We will just delete the value here and increment the value there. So int current value equals to map y x. Then if map y x but x plus 1. Let's go back to the drawing board. If we have a value stored here, why do we need to check it? If it is here and we go right, we don't really need to check it, because it will just be pushed against this wall, so it will be stopped immediately. So we don't really need to check against it, so we can make it map size -1, map size -1. That's the way for us to not encounter a seg fault or a stack overflow. So we check the next position, and then if it is 0, so we can just say this. If it is 0, then map y x plus 1 is equal to current value. But if map y x plus 1 is the same as current value, then we need to make it current value plus 1, because we'll increment like it will multiply by 2. It will be made it will be twice the value, but we store only not the values themselves but the powers of 2. So we need to increment the power of 2 by 1. And there is another way it can happen. There is another possibility here. Let's put else, so it doesn't check this if this was right. There's another possibility. If map y x plus 1 is not the current value. If this is the case, then we'll do nothing, I guess. Yeah, we will just do nothing. So here we also need to clear this value. So map x equals 0. Here we also need to clear this value, and here we don't need to clear this value. And another thing that I've noticed is, so again, back to the drawing board. what if we have this kind of configuration? Let's put it like side by side, our implementation and this configuration. Okay, it will check from the right to the left, so it will check this value first, and it will check, okay, is the next value the same as this value? 4 is not 2, so it will say no to this. It is not it is occupied, so this will not work, this will not work. It is not the same, so this will not work, and it is not the same, they are not the same, so this will work, but it doesn't really do anything at this point. So okay, this value stays at the same place. Then we go to the next value. We check, is the next value occupied? No, it isn't. Is the next value occupied? No, it isn't. Is the next value occupied? Yes, it is. No, it wouldn't really go that far because, okay, doesn't matter. It stays here, but you see the problem, right? This value was already checked before this value was updated, and it stays at the same position. So what I think is we need to check from the right to the left. So let me move okay, so let me move it back if I will be able to do it. Okay, so let me move it back. It will start from this position. Okay, it is empty. It will go to this position. It is empty. It will go to this position. Is this position occupied? Yes, it is. So it goes here, then it goes here, then it goes here. Okay, updated. Go next. Next position is here. Is it occupied? Is this position occupied? No. Goes here. No. Goes here. Yes. Stays there. So we need to check from the right to the left. From right to left. But we also need, if we have our value here, we need to check the next value from left to right. And it poses a problem. We need another layer of a for loop. Instead of introducing a new loop, let's make a function that handles moving only one cell at a time. So okay, we might pass in the position x and the y position of the cell, and then we go here and make another one, another cycle, another for loop. So in x, oh yeah, we also have this. So if dir equals is, because it wouldn't work in any other, for any other direction. It will need some other code, some other piece of code. So x less than map size -1. Okay, let's actually put it like this. So int x equals x. Let's actually make it I, so we do not mistake one for another. Okay, so we start at the initial position of this value. We go to the right, and then we check if this value is not null, if this value has, if this value has the same, this cell has the same value, and if the cell has not the same value. So if okay, we'll put map current value here. So okay, overall our code can be simplified here. We can only do this and make it here move one cell and pass x, and y here. So now our code should work, only if we have here like map size -2. Here we also have map size -2. Here we have map size is more or equal to 0. And here we decrement it. Okay, we can put it here. Rex. So I guess it should work. We'll see if it doesn't, but it should. So if I'm not mistaken, yeah, that's all what that we need. Is it? Okay, let's try. Move cells. And let's copy and paste. I can actually, no, let's copy and paste it. Yes, because if no key is pressed, we don't want to move cells to the right or to the left, etc. So, okay, I think that's all. Let's, call this function every tick. Oh, and also let's put the set target FPS to 60, so it doesn't go above it. FPS. Oh, okay. I don't have any value at start, so 0 is equal to 1. Okay, let's go. Okay, something isn't right. So I figured out what the problem was. Here I passed x without instead of I. So here we go through values of I and we need to use them here. And here I made a really interesting mistake. Here I check for non-zero values at needed coordinates, and here the coordinates were swapped, so I messed this up and I needed to swap them back, and now everything works. I go right, it goes right, and if I didn't really check it, so let's try it. If I make it like 1 and here I put 2 in here, so yeah, it goes here. But if I make like another one, like it's the x equals 3 and make it also 2, does it go together? Yes, it works. It works exactly as I needed. So we're almost done, except we need to make it for every direction. So firstly, what we need is we need to figure out the most painless way of switching the directions. For example, we can omit this, we can like entirely delete it, because we can check for the direction here. If we have here west, north and south, let's even swap it like east, north here, west here, and south here. and let's put, okay, let's put it there. So now what we need to do is go take all of this and mess with it a little bit. So now if it is directed north, i.e. upwards, I hope I will be able to pronounce it. Upwards. Okay, never mind. So if we need to go that direction. Okay, let's go with south first because it will be easier. It will be much easier. We would just need to swap y and I. Here we need to the here, here. Okay. We just swap these two variables and we should be alright. We should be alright. Okay, there are some syntax errors. Okay, I hope it works. So if we go down, when we check for the values here, we need to check for y values. Yeah, y values first. Okay, I pinned it down to one problem. Here we had map size -2, and the logic there was that it will check only for one direction, only for the westward direction, and all of this logic was here, so it was necessary, but now it's not necessary. So now we change these tools here and here to ones, and now everything works as predicted. Okay, we only implemented two of the axes. Now we need to implement other axes. So now what we do is the south direction is the same as the north direction, but in the north direction we go upwards instead of downwards. This means that we go towards the negative value of y. So then we need here to go y minus 1, I minus 1, and we need here to go from map size -2 to y position, and here we decrement our I instead of incrementing it. So I think everything should be fine. Yeah, let's try this. Okay, and no, it doesn't work. What's wrong with it? So let's check. Here we need to go this way and this way. Yeah. So we need to go from the last position on the y-axis, but we need to only go to the second position on the y-axis. So back to the drawing board. Why do we need to change the values here? Because, as stated, if we have if we go upwards in the upward direction, if we have this value here, it doesn't move anywhere. It stays at this place. It can't go up anymore. So here, from the latest position, we go to this position, and we don't count this position as a valid value for I. So I guess now it should work. If I run it, yeah, it works. And now I copy the east part of this code to the west part of this code and do the same thing. I will copy this here. Here I'll change it for x, and here I will change this to -1, from +1 to -1 to -1. And here I will we need to increment it by 1, so yes, we need to increment the value by 1. So I guess everything is done. So let me try to do it. Okay, we have a problem. We have a problem. I identified the problem. So you see, if I put them in, if I put them vertically, the same thing occurs. So I go downwards, southwards, there is no problem. I go up, there is a problem. So what problem do we face here? When we go upwards, so by the way, our representation here is misleading. We when we go up, we go south, and we go down, we go north. Renderers work a little bit counterintuitively. Renderers render from up top downwards, so then they number pixels again from top to bottom. So this pixel has 0 y coordinate, this pixel has like 800 y coordinate, so we need to flip the image 100 degrees and 180 degrees. We'll do this, but a little bit later. So now we encounter, when we go south, we still have some kind of a problem here. So let's investigate. When we move south or we move westward, we need to have initial cycles, not from right to left, but from left to right, and not from bottom to top, but from top to bottom. So because then if we check this piece first, then it will think that this place is occupied and it will stay in place. But then this thing moves up and this thing still stays here because it thinks that this place is occupied. So when we go from bottom to top, bottom to top, we need to check not from like bottom to top, but we need to check from top to bottom. Okay, so then we can check if the direction is like east, so in the positive x direction, or if the direction is like, I mean south, which is the positive y direction, then we do this. Yeah, but else, if the direction is north or west, we do the opposite thing. We go from like from 0, we go from 0 to map size -1, and here we increment. Here we swap y for x, and now it should work perfectly. Yes, it works perfectly as expected. I previously stated that the values are swapped, so y axis is actually mirrored, so what is on the top actually is on the bottom, etc. But let's just pretend it's not, because everything works perfectly fine and we probably here just live on the other planets that where, or we have another map that is flipped upside down. It doesn't really affect any inner workings of our program, and our program works fine, so we should not really, if it works fine, let's not change it. Okay, we just know that south is upwards. So now what is left to do is to populate our map each time we make a new cell. So let's include std_lib. Okay, if I'm not mistaken, it is the library that is needed here. Okay, let's try rand. Yeah, rand works fine. Let's make a new function that will populate our map with a value each time we press a key. Create a cell, probably. So we check a number. We need to have an X position and a Y position. It will be checked by a random function, and we will get a number from 0 to map size. Okay, if I'm not mistaken, rand returns integer value, so we need to get the modulo of this value. And here we also need to have a y value, a random y value. So we need to get a random position, but what if the random position is already occupied? For example, it picks the position 3,0, and this position is already occupied by 2. So what we need is try to calculate a couple of random positions, and if none of them work, go for the leftmost upmost position that is not occupied. So it will check this and this and this and this, and it will check for every value, and we can accomplish two things at once. Firstly, we can get a pseudo random position, and then secondly, we can see if the player has lost already or not, because the player has lost if there are no empty places. So if every place is occupied, then you have no moves left. Yeah, let's have a new like for loop, and we will have number of tries in here. We will have a maximum number of tries, for example 10, and incremented each time that we go through this loop. So we have 10 tries, and at each of those tries we get this random position, and we check, is this random position, if map yxy is not 0. Okay, if it is 0, then we found our position, and we simply create a new cell here. So we just make a new cell, and we do it by providing the coordinates and assigning a random value to it. So the value will be from 1 to maybe 4. Okay, I think 4 is good enough. A random value. Okay, so it will have, actually, the amplitude of this random distribution will be only 3, because the minimum value is 1 and the maximum value is 4. So the amplitude is 3, and then we just add 1, because 0 is also possible. So 0 plus 1 equals 1, and 3 plus 1, there we have 4. 3 plus 1 equals 4. So okay, and then we just return. But if we didn't succeed and we didn't really find an unoccupied position by having a random value, then we need to go through all of the values and find a position that is not occupied. So we'll have to go for all of the positions. So again, a double for loop, and then the same stuff. If this place is not occupied, then go and return. If it isn't, then continue. But okay, we already returned from this function, so we don't need to go continue anyway. And if it doesn't still get an unoccupied position, then we need to just declare a player has lost. The player has lost. So we need to have a new value is lost. Yeah, has lost. And it will be defaulted to 0. And here we declare it as lost equals 1. So if we couldn't find an unoccupied position, then the player has lost. So each time we create cell, times that we move, we create cell. And okay, I think that's all. We now need to like show the player if he has lost, then I don't know, maybe close the program, but we will do it the other way. We will just, if the player has lost, then we will go out of the loop. If he has not lost, we go into the loop, and if he has lost, we go out of the loop. And then we just draw text, a new text. You lost. Let's draw it in the middle of the screen. So 800 divided by 2, and here also 800 divided by 2. The font size will be our regular font size, and the color will be red. I love red color. So we need to go to the right a little bit. Okay, so you lot is 1, 2, 3, 4, 5, 6, 7, 8, 9 characters long. So let's go to the left by 4, and here we go to the and here we go up by 1. And now get char. So we wait for input, for some kind of input from the player, and so it doesn't go out of the game immediately. And yeah, so let's try. What the hell? If it isn't populated, if it is populated, then it will be not 0. But if it isn't populated, then it will be 0. And we need to negate it. So now it should all work. Yeah, it works. It works perfectly. So right here we have two 16s, and if I go right, they become a 32. So let's type in some gibberish so it makes some numbers. And here, yeah, and here I lost, so it doesn't wait for user input because get char is a command line function, but it still knows when you lost. So yeah, and now we have a working game. I hope you have enjoyed coding with me. Yeah, it's alright. Yeah, it works. It works. It really works. Yeah, it does. I love playing this game, by the way. I haven't played it in a while. Okay, I've lost. Okay, let's try one more time. It's interesting. 2, 4, let's go up here. If I go down, no, it wouldn't work, but we'll have a 32. Here we would have a 4, here 8, 8, 2 8s, and then a 16. Okay, so now we would have a 32 here, a 46 here. We don't have any. Okay, don't have any. A 8 here, a 2, a 4 here, a 32 here, and a 16s here. Here we have a lovely 3 8s, 32, 64, 128, 64, 8, 16. Okay, I'm losing now. 64. Heck, 8, 8, 16, 32, 256, 32, 8, 256, 32. Okay, it works, it works magically. 60, 16. Okay, I don't really know. I don't really have any options. 64, 4. Okay, is it so? 8. Hell. Yes, it's all. Okay, the game works and I've lost a couple of times, so it really truly works because I always lose this game before I get a 2048. So yeah, this was the first video in the series. I hope you've enjoyed it. I hope I have maybe inspired you, or maybe you have implemented this game yourself. Maybe you have implemented it more cleanly, more easily, more full. So if it is true, then tell me in the comments, and I'll also maybe in the follow-up video I will also maybe tell about the improvements that I would make on this game, because I know this game can be improved, at least visually. Okay, so it's already late here. It's very late, and I really need to sleep. Thanks for watching. Goodbye.